Alright folks, we're going to get started in just a minute here. Just hang tight. Alright, cool. Welcome everybody to Study Hall. Let's see. 1 second here. This is a place for you to come and ask your questions, and I'll take them on stream and go through the answers, talk about solutions. So if you have any Python questions specifically, beginner, any intermediate Python questions, bring them in, provide a link to where the question is from, or if it's just from something that you're doing, provide just whatever context if necessary, or just a link is fine. You can send me your code and I'll troubleshoot it. You can tell me what error you're getting and we'll talk about that. So yeah, feel free to bring in your questions. Just pop them into the Slack thread. And that reminds me, let me pull up Slack on my phone so I can monitor what's going on. It's been a bit of a full day today. It's a fairly busy week as well. So I am just getting this put together at the moment. And yeah, so I'm a little behind. Apologies for that. All right, so I'm not seeing any questions at the moment, which is all right. If you do have any questions, feel free to pop them in there and I will go over them. Also, feel free to just say hi if you're around. Just say hi in the Slack thread and I'll say hi back. All right, so since I don't see any questions, I'm just going to go through where we left off in the material. So we're really early on in the material. We're covering scalar types again. This is going over integers, floating point numbers, booleans, strings, and none types. So these are our scalar types, our sort of simple types that hold simple objects that are capable of holding a single value and not mutable, so they can't the value can't change. We can obviously, there can be a variety of values, but the value doesn't change on the level of the data type itself. Okay, cool. So I think I'm just going to kind of go over these sort of together. This is going to get into using variables and reassigning a variable that has an integer and using that variable with an integer that has a value of an integer. So let's just start playing around with that. So integers, as the name suggests, are just whole numbers. They can be positive or negative, and specifically they don't express a fractional component, so they only express, like I said, whole numbers. Floating point numbers can express numbers with fractional components in the form of a decimal. So if I say, 5 or 7 or 293,411, those are all integers, because these could be negative numbers, whatever. One thing that'll kind of get you sometimes, not always, but if you are making a negative integer, it's a good practice to always put parentheses around it. That way you're sure Python will evaluate this in the order that you want. There are some weird things with order of operations where you can do something like, if I wanted to get, if I wanted to raise, yeah, let's just say I wanted to raise -3 to some power. If I say print -3 to the third, so that's going to be different than that, or that's going to be the same in that case. So if you want, you have to be sure that you're making the number that you want to be negative, right? So things like that. There are certain situations where that can really mess you up. So it's a good practice to just put parentheses around all your negative numbers. I guess that's the situation I'm thinking of. Is that the one? That versus that. Yeah, that's what I'm trying to. So it's with squaring particularly. So you can see in this case, -3 squared is -9 versus -3 squared is 9. So used a weird example there at first. So anytime you're making a negative integer, and this goes for floats as well, just stick the whole number with the negative sign in an extra set of parentheses, just so that you're sure it's going to evaluate in the order that you intended. So let's just look at a variable with an integer. So I'll just call this num, and let's just start this at 0. Let's print num. I've given examples of this with when we were talking about variables as well. But we can reassign a different value to num here. We can say num plus gets 1. So you see num starts at 0, then we print it off. We're going to get num is equal to 0. And then let's do this a few more times. 1, 2, 3, etc. Right, so a line like this with num plus gets 1, this is syntactic sugar for, oops, for this line. And what I mean by syntactic sugar is that this is just a nicer, sweeter way of doing this line. It's a nicer way. It's like putting sugar on top. It doesn't actually do anything different. It's when you hear something called syntactic sugar, it's just like it's syntax that makes something that's a little clunky feel a little nicer. That's all syntactic sugar means. In this case, I don't find this that clunky either way, but yeah, this is a common thing for languages to do to shorten this in that way. So this line internally in the Python interpreter, once this document is run, this line actually literally gets turned into that line. So the way you can think about it is this num plus part gets copied and then just pasted in here like that. So that's all that's happening with that. Of course, we can add any number to this. And we'll get different results. So this will count us in threes, and I could count us in different increments if I wanted. So yeah. So as you can see in the print here, I'll just make a new little section. As you can see in the print here, and we kind of covered this when we talked about variables, I'm sure. If I define an integer, let's just say 73. If I define an integer, I can access the value of that variable by just placing in the variable name. So num is the variable and its value is 73. So if I want to do 73 over 2, I can say num over 2. Something like that, 36 and a half. Okay, cool. All right, we got somebody saying hi, hello. Welcome everybody. Oh, we got a couple people saying hi. Hey there. Yeah, if anybody's got a question, feel free to pop it in. We are open for questions at the moment, just going through the material, talking about integers and floats and stuff. But I'll be happy to get to a stopping point with this and take anybody's questions if I see any. Cool. So we've got our excuse me, we've got our values here. Let's see, I'm just trying to see if there's anything interesting we can talk about with floats. I mean, they're pretty simple, you know, they're numbers. Not that numbers don't get complicated, but you know, just the number itself. Everybody knows what that is. I assume if you're here, you know what the numbers are. Okay, cool. So the int type, is the int data type built to hold decimal places? No, that's the float data type. In the example function above, get middle letter, let's see where it says that. Okay, just copy that. Can a non-integer be used to index a string of characters? Oh, this is actually a great point. So this is something that's really useful about integers. When we talk about strings, or lists for that matter, let's do a list of we can use, and there are various other data types that we can use indices on. So both of these have the capacity to be indexed. And why don't I do this? I'm just going to call it object like that. And then in either case, I'll print obj. So I'll print the object and I'll index into it at index 3. So if you know about indices, you'll know the indices start at 0. So the character at the third index in the string is HELL, so that's 0, 1, 2, 3. So that's the second L. And then the character at the third index in the list is 0, 1, 2, 3. That's 22. So that's L and 22, right? So you can kind of think about this a little bit. And think about, if you're familiar with floating point numbers, think about what would it mean to pass a floating point number as an index, right? what would that even mean? How do you get the third and a half element in a character, right? I don't know, maybe you could do something weird where you like go into the ASCII codes and like get the byte that's represented by half of the last half of the L and the first half of the O. Somehow that doesn't seem like a great solution to this. And I could probably think of, I don't know, if I sat here, I could probably think of 4 or 5 more other ways that this possibly could be interpreted, but similar to that, they probably wouldn't be good. They probably wouldn't be behavior that you would actually expect or want, you know. So as a result, if I try to use a float to index into something, I'm going to get an error. So this says type string indices must be integers, right? And we'll get the same thing. List indices must be integers or slices, not floats. It's kind of weird that those errors are written different when they're so similar, but yeah, so this is telling us that indices for these indexed types, have to be integers. And you might think, okay, well, you know, maybe it would be sufficient for a float if you if it were a whole number, right? Because 3.0 is the same value as 3. The float 3.0 is the same value as the integer 3. They're equal in value, but this is still an error. It doesn't matter the value, even if you use a float that has a sensible or a rational value to use, you know, because this is still saying give me the third element. The fact that it's a float still means that it won't work. So I wanted to mention this because it's something that comes up occasionally, where you're trying to index into something and you get this error, and it's because you're trying to use a float to index into an object when you need to use an integer. It's required that you use an integer there. Cool. So in the example above, can a non-integer be used to index the string characters? Will mystring 3.0 return the characters in the third index? Assuming that mystring has at least oh, excuse me, is at least of length 4. Okay, all right, that was worded a little weird. I was being dyslexic on this is. Okay, so that's going to be a no. Can't use a float. Write a function, divide by 7. Def, divide by 7. Good. Okay. I know this is just a little quickie function, but I want to bring it to your attention that notice the order that I did this in, and I'll actually do this again. This is pretty important. It's going to save y'all a lot of work down the line once you get into this habit. And basically everybody I know is more or less in this habit somehow. There's different ways of doing this, but at the end of the day, you're testing your code. So I always write an invocation of my function def with my function definition, right? And now I can work on my function. That way, if I need to run it, test it, do whatever I need to in the inside of here, I have an invocation of it. Now, this isn't complete because presumably I'm going to take an input, right? Doesn't need to be complete yet. You know, that's the point, but just have at least one invocation while you're working. It'll save you a lot of headache. You don't have to start at the top of the document and then just work your way down methodically. You can kind of work all over, and you'll end up working in the middle of a document most of the time you're coding anyways. So, all right. write a function called divide by 7. This function will take a number as an argument or parameter. So let's just call this num. And I don't know, 14. I'll do 14 because this is called divide by 7. I wonder what it's going to do. It will divide the number by 7 and return the result of the operation cast as an int. So it's saying specifically casting, right? So if you're familiar with your, well, I talked about integers. I didn't even talk about the mathematical operators. Yeah, I guess I'll cover those in a second. So, and I see, it looks like we have a question here. I'm going to finish this up real quick, and then I will get right to your question. So if you're familiar with your division operators, you know that we could return num over 7 with a float. That'll work, except it gives us a float. Oh, excuse me, I said float. Num over 7 with a single slash. And I think of this division operator as being related to a float because notice the inputs into this operation are both integers. 14 and 7 are both integers, and it gave me a float back. So with any of the mathematical operators, and why don't I just demonstrate this really quickly. Let's do 4 plus 3, and I'll just do this with floats. 4.0, 3.0. Well, I need to copy this evidently. Okay, so we have some different, just some kind of variations of this, right? We've got two integers, float and an integer and float, and then two floats. So what are the return types of these? So if I run this real quick, notice I'm going to get an int followed by 3 floats. So I get an integer followed by 3 floats. And this pattern is true whether we're adding, subtracting. Why don't I just comment that out for now, right? Multiplying, adding, subtracting, multiplying, but not dividing with a single slash. There are two division operators, and there's another operator that is related to division that gives us the remainder. That's called modulo, right? So for this one, they're all floats. So why don't I actually map this out the proper way? We'll do this. So plus, minus, times, divide, 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 power. Okay. So this will be minus, this will be times, divide, and this is the exception where all of them are floats. Then we have double slash division and modulo and then power. Okay. So I know that's a lot. Why don't I label each of these? label these real quick. Plus, minus, times, divide, divide, remainder, exponentiation. Okay, so, oh gosh. I should actually be getting the type of all these. Let me just do that really quick. I'll do this. Perfect. Okay. There we go. So this will actually show us the pattern. We got quite a bit of output here. So for addition with two ints, we have int, float, 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 int, float, 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 int, float, 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 and then single slash division always gives a float back, and then the other three operators still have that same pattern of int, float, float, float. So this is an exception, right? So in terms of this problem, you might think, oh, well, maybe I'll use the double slash division operation here, right? But that's only going to work if both of the inputs are integers. Why don't I do this really quickly? Just comment that out because we don't need that output anymore. So this is only going to work if both of the inputs are integers. If I have a float, it will round to a whole number, but it won't, it'll still give me back a float. So 14.3 over 7 is not exactly 2, but it still gives me that 2 with double slash division. So that's called floor division. So what I prefer to do when I need the result, and this happens fairly often, you'll be surprised how much I encounter this exact scenario where I need the result of a division operation to be an integer. What I prefer to do is single slash division and cast as an int, right? And that guarantees no matter what, and I guess, you know, I only have two things I can do here. That guarantees I always get an integer, right? So I only have two scenarios because, at least with the types, because I can't change the 7 to a float because it's baked into the function. So all I can do is pass in either 14 as an integer, either a number is, I can pass this in either an integer or a float as an argument. So in that case, they want that cast. I have people ask me a lot of times, like, reason I wanted to go into that is I often get asked like why I don't use double slash division in places. And for a while I kind of had, I was just like, oh, I just like to do int, and I had to kind of feel it out and be like, oh right, usually the reason to use double slash division at all is because you require an integer. But you can see that, you know, the output pattern for its inputs, you know, most of the time it'll give you a float anyways, so. Cool. All right, on to the next one. So I'm actually going to take this person's question. Sorry to keep you waiting there. That question had enough in it, and it had enough things in it that were like sort of common things that I get asked about, I guess, regarding double slash division. I think a lot of people are curious about it, but yeah. Okay, let's take this question. Stuck on challenge 3 at this link. Can't get it to work. My messy code so far after different trials. Okay. So number 3, oops. You didn't see any solution. There was no solution there. Ignore the solution. It's not real. Okay. Don't look. That's not a solution to the problem. Let's make that go away. Okay, good. So this is what we've got. So at this point, so I'm looking at these errors, and so it's failing 2 of our internal tests. So I'll show you how you can kind of work with these. It takes some getting used to. Learning to read errors just does take some getting used to, and that's all right. So here's the code as submitted. And then, so what I'm going to try to do here, now I actually have to, I need to read what this is supposed to do. Write a function called string op. This function takes 2 arguments. The first one, called string, is a string on which an operation will be performed. The second one, called command, can be any variation of the word upper, lower, capitalize. For example, this could be spelled upper, etc. This function should return a new string that is a result of command. If the command is invalid, return invalid command. Okay, cool. So, interesting. So, what I'm seeing here is this this check for membership, and I see this like lowercase u, lowercase p, uppercase p, etc. In list command. So command is being made into a list in this case. So let's talk about checks for membership real quick. So if I take how do I do this? Well, let's just isolate this. If I check if this list is a member of, let's just do itself, right? It should be a member of itself, right? But it's not. So what a check for membership does, and I know this is a check for membership because it has the n. It's seeing, is this inside of this other thing? What it's seeing, it takes this quite literally. It looks for this single object, this exact list, and it checks if it's inside of whatever thing I'm asking here, right? So I would have to put this inside of another list, and then that would be true, right? Now it's a member of that list. So if I take a command, and let's say I do upper, if we do this, we're going to get an error. Oh, of course, that's not what you're doing. Sorry, you're doing this as a list. Probably found that out. So this is still going to be false, right? Because we're still getting, you're seeing if this exact list is a member of this list. And if why don't I just make this a list here? Oops. If I print out command, we'll see upper, right? So there's an analogy here to be made where all the letters in the list form of command are in this particular list, but they're not exactly in the same order, and that's what counts here. So fortunately, there's a much easier thing we can do here, and we don't have to use lists at all. So let's do something like upper. So in this case, we can use string transforms. So I can do cmd.lower like that. So cmd, notice if I do cmd just on its own, command, on its own, I get the upper version, right? And if I do cmd.lower, so it's kind of funny, right? Like the result of this is a string transform, but to solve it, you actually also need to use the string transforms. So what we want to know is if regardless of the casing of whether it's upper or lowercase or mixed case or whatever, of the command word that we send a string off, and let's try a few of these. Let's do, I'll do this, res equals this, exp equals this, and we'll print res equal exp, comma, res. So I'm going to make up a little test here, and then let's say, oops, hello world, and let's say, let's just steal this one real quick. So if I want to do upper here, my expectation for this is going to be hello world like this, right? And let's just try some more of these. Let's create some more expectations. So if I do, I'll do hello world again, I'll do the same input, and then let's do lower. So that'll be, oops, hello world like that. And I recommend that you do exactly what I'm doing. You don't have to do it exactly the same way. I do this result, expectation, print res equals exp, and res. I just do this. This is my little quick, easy test that I do in this way, but this is my way of doing it. But just write, it doesn't have to look exactly the same. It just has to have, you have to make a call to your function, print out the result of that call somewhere, which I'm doing here, and then if you can, take some time to say what you should expect from that particular function. Okay, so next one is capitalize. So say capitalize. Capitalize. And why don't I do lower like this? Okay, so I've got all of these commands entered in a really funky way, with the casing where the casing is all random. So notice in all cases, I'm getting this invalid command returned. So no matter what, it's going to return invalid command. So what we can do instead is I can just check if command, and the standard thing to do when you want to standardize the case or when you want to ignore case is to lower it. So I can say command dot lower equals upper, right? So if I lowercase capital U P P capital ER, right? If I lowercase this string, I get this string. So command dot lower equals upper, the string upper, then return string dot upper, and then from here it's just the same line with a different command, and that's it. That's really it. So this is going to be lower. This is going to be capitalize. Now there is a yeah. Oh, I was like, wait, those should be true. I forgot the commas. And then capitalize should just lowercase everything except the first character, which should be uppercase. So that's true, true, true. That means my tests are passing, and I'm seeing the results there. Cool. And let's go ahead and submit this into Learn, see if it agrees with me better. Okay, cool. Let's look at my code. Let's see what I had. I don't exactly remember what I had. I think it's just exactly the same thing, just with things squeezed onto a line. Yep, it sure is. So if you if the consequent of your function is only one line, excuse me, if the consequent of your condition is only one line, you can put it on the same line. And sometimes I like to really square things up and make them all pretty like that. But at this point, you know, it's exactly like the code that I had initially submitted. Run tests. Cool. Let me know if that was helpful. Cool. All right. Cool, you're welcome. Glad that was helpful. All right, feels a little a little disappointing to just go back into floating point numbers here, but you know, I feel like we can kind of want to skip ahead a little bit. Oh, we should talk about this. Cool. Just to be clear, thanks for the question. The floor is open again for questions. I don't see another question. To anybody who has one, I think there's just a few people in study hall today. Yeah. So if you've got a question, feel free to just throw it in there and I'll be happy to take it. In the meantime, I'm gonna start going through the float stuff here. And I keep doing this thing where I'm like, oh, we don't need to talk about this, and I scan through the lesson and I'm like, we should talk about that. So underflow. Underflow is something that's worth, it's kind of worth knowing about. It's not really something that causes you a problem that often, but if it does cause you a problem and you don't know that it can happen, it can be a really weird, it can just look like really strange behavior. Because it's not a formal error. So it's sort of a runtime. It can look like a runtime error, or it can be, you could consider it in certain cases, you could consider it a runtime error. So I'm just going to mention this as something that you can be aware of, but you don't necessarily have to commit this perfectly to memory. So as a side note, you should familiarize yourself with the concept of underflow as it relates to the float data type. Underflow can occur when attempting to calculate a number smaller than what can be stored in memory. As alluded to before, integers are stored differently than floats. I didn't mention that today, but they are. An integer is more or less a direct representation of its binary form. For example, here are binary representations for integers from 0 to 15, only positive numbers greater than or equal to 0. So those are more or less how integers are represented. It is correct. It's a little more complicated than that, but you kind of get the picture. The structure of a float is significantly different. You can read this Wikipedia article. Why don't I paste that in there if you do want to learn about floats. This is something I mention a lot but never really dive into. If you're curious on how to convert from float representations to decimal, for now the key takeaway is that you can just count binary for a float. And a fraction cannot become infinitely small. So that's the important part that sort of bears on underflow. A fraction cannot become infinitely small. At some point you will underflow because the computer can't represent a number that small. You might encounter issues when comparing two float values to each other. This can also lead to unexpected behavior. That was the unexpected behavior that I was talking about. When you decrease the size of the float towards an infinitely small value. I would rephrase this when you, this kind of makes sense, like decreasing the size. What this really means is when you make it more and more precise. So the longer, like the tail or the part of the floating point that is to the right of the decimal, we say the more precise it is. And there is a limit to how precise it could be. There are some ways around that limitation, although you just start sacrificing more and more computing power to make a more and more precise float. So, let me see if I can cause this to happen. So you can see this is going to be a very small fraction. We're going to get a really precise float. And this is actually going to give us this E notation. This is 1e minus 20. And this will go on for a little bit. We're already out of kind of conventional E notation. So at this point, you can see it underflows. So we've caused an underflow. My computer's CPU is no longer capable of calculating a float with the default Python float any further than this. This is not happening out of a matter of convenience. It's not saying, oh, well, you probably wanted this to be 0. It's so small anyways. I'll just make this 0. this is because my machine just literally can't calculate it any further. So we've reached a limit to what my machine can do with the standard Python float. So there are other more precise floating point data types that you can get from other libraries. I haven't had to use them, so I don't know them off the top of my head, but I do know that they exist. So if you're ever doing something where you need like 32 decimals of precision or something, or I guess it'd be 31 decimals of precision or more, such floats exist, but you have to go like find them. Okay, cool. Are there any inherent limitations when using the float data type with extremely small numbers? Yes, that's the only thing we discussed about floats. The float type. Which of the following statements is not true? Or is false? A float can only hold a certain amount of precision on the number of bits it has been allocated in memory. I think that's true unless there's some trick being played. When calculating floats assigned, when comparing floats against each other, Python will automatically check if they are close enough to being equal. So it can seem that way if you're in an underflow situation, but that's actually not going to happen. Python will make no assumption. Like if I have some float, let's say 3 point. This is actually another way to show underflow. Oh, I gotta assign it num. We'll do this. This is actually another good way to show underflow, right? I've asked it to represent a number that is more precise than it wants to represent. So it actually stops. It just cuts it off right there. Essentially, it rounds it. So Python will make no assumptions for you. So if I say num1 and num2, and I say num1 equals num2, these two are exactly the same. I just copied it over, duplicated the line. Oops. Oh, I was like, wait, what? I just put 2, not num2. Okay. So num1 and num2 are exactly the same. So let's just say I make the smallest possible change from the least significant digit in the smallest possible increment, and we're going to see if these are equal, and they are no longer equal, right? So even though these are as close as they can be to each other while not being equal, Python's not going to do us any favors. There's no point at which Python will say, oh, those are basically the same. They're either Python thinks they're either exactly the same or they're different. So this is about as little difference as two floats can have. And Python still doesn't consider them equal because, you know what, they're not equal. Okay. Write a function called multiply by 3. This function takes any number as an argument or parameter, which it then multiplies by 3 and then returns the result of that operation cast as a float. Okay. I'm not, of course I am. I was like, I'm not going to bother writing a test for this, and I was like, I made such a big stink about it the last time. I kind of am obliged, aren't I? Okay. Test. Okay. Just write it, even if you don't think you need to. So we just expect the number multiplied by 3 as a float, so this should be 12.0. Yeah, so let's just return n times 3.0, and this actually always will give me a float. We'll take in n. So this will actually pass the test. Remember in the last one I had to put, when I wanted it to be an int, I had to be like, nope, give me an int. And I had to specifically state int. I had to cast it as an int. Well, given the output pattern for multiplication, right, if either of the inputs are a float, or both, then it's going to return a float. So I know if I just make that a 3.0, it's always going to return a float for any input. This does say cast, so I'll play fair. We'll do that. So I'll submit this just as is, just to show you. It's always going to produce the correct result. So even though I didn't cast, I technically broke the rules a little bit. It's always going to produce the correct result. So that's what's important, right? So if it always produces the correct result for all the tests, then you know it's working. So, but you could also, if you wanted to play by the rules here, you could also cast as a float. Either way. Okay. I do want to give folks a minute before we get into this. If anybody has another question, please bring that in. I'm just going to put a minute or two on the clock and just see if anybody's got a question. Okay. Cool. All right. Booleans. So let's talk about Booleans. So Booleans, or a bool for short, might sound like kind of like there's something to it just based on the name, like there's something kind of complicated to it. They definitely show up in places. There's a lot of parts of your code that express Boolean values, but Boolean values themselves are really simple. There's just two values. You've got true and false. And notice that those are, as I'm typing them, they change from that white color to the orange color because that's how my syntax highlighting highlights them. But that tells you that these are actually the values themselves. These are literally Boolean values. TRUE, FALSE, those are the values. So not too much going on there, but a lot of operators and operations and a lot of functions as well will return Boolean values, and Python conditions in control flow, writing conditional logic is contingent on utilizing those systems that give back Boolean values to determine whether or not code should be executed. So they're central in that regard, right? So there's two things that I kind of mentioned there. One is, one is that there's parts of the code that give back Boolean values. Sorry about that. Parts of your code give back Boolean values, and other parts of your code expect Boolean values. Let's say expect / utilize Boolean values. So they utilize them in kind of a special way. So there's sort of special, I guess. So in terms of things that give back Boolean values, we've got basically our comparison operations. So if I say 3 equal to 0, I don't know why I put a comma in there, or 3 equal to 3, right? False and true. Let's say I can do the same thing with not equals. Not equal. So I've got equal, not equal, greater, less, greater, equal, less than, equal. Okay. So let's do greater than, less than, greater than, less than. So these are your comparison operators. Oops. Because they compare true or false whether the thing on the left is equal, less, not equal, greater than, etc. Right? They make that comparison, and they tell us true or false whether that comparison was true or false. So these are really common to use, and the other part, which is the part of your code that expects Boolean values, if, or I said of, if. So if I say if 3 is less than 5, print the condition was true. Else print else, else print the condition was false. Okay. So the condition was true, and then if I flip this around, and the condition is false. So this gets us into control flow, and obviously control flow can get a little more complicated than this. There are a few other scenarios where we have elif, which is kind of a combination of else and if. It's like an else that allows us to check another condition, which is again the definition of a condition that I use is any part of your code, any expression in Python that expresses a Boolean value. Because if something expresses a Boolean value, you can use it as a condition. So that includes like a function that returns a Boolean value. So why don't we, let's just actually look at one of those. Let's make an is prime function. Def is prime. Print is prime. And let's just say for num in range 20, I'm going to call this I, and I'm going to say I is prime. And is prime, like a lot of functions that start with is, if a function's name starts with is, it probably returns a Boolean because it's like is prime, like what's a good response to that? True or false? Is prime n true or false, right? Sort of syntactically a little wrong in English, but you kind of get the gist. So I'm going to say let's handle our edge case. If n, and I forgot to take in n, we want to take in n. If n is less than or equal to 1, so we're testing this condition, this is going to give us a backup Boolean value. If n is less than or equal to 1, we're going to return false. Okay, and then for I in range, and we want to check a number of numbers. We want to check a group of numbers to see if this value of n is prime. So we'll go from 2 up to the, let's just do half of n. We can actually do the square root of n, but I'm just going to keep it simple there and just do half of n. We don't need to. Do we need to? No, we don't. We don't need to. We might need to include it. I forget if you need to include it there, but I could think through it, but I'm not gonna. Then if at any point we find if n over I has a remainder, so I'm using the modulo symbol to get the remainder. So if n over I gives me a remainder of 0, then I know I divides into n evenly, which means it's not a prime number, so we'll return false. If we make it through checking all the numbers and we didn't return false, then we can return true. Bingo. So 0 and 1 are false, 2 and 3 are true, 4 is false, 5 is true, 6 is false, 7 is true, 8, 9, 10 are all false, 11 and 13 are true, etc. Right? So now let's just do this. Let's do something like if is prime I, print I is a prime number. And this will only print out, it'll only print that out if I is a prime number, because I'm using, so this function returns a Boolean, and I'm using that in the condition portion of this if, because a valid condition is potentially anything that returns a Boolean or that evaluates to a Boolean. Since this function, since I wrote it to return a Boolean value, I can use it to control this if. So this returns true when the number is prime, and therefore I can run my code when the number is prime. I could say I is a prime number. So it says 2 is a prime number, 3 is a prime number, 5, 7, 11, 13, 17, and 19 are all prime numbers. Cool. So I know we kind of got into is prime there, but that was, about Booleans, and hopefully that's clear. Show you some different ways that you can utilize Boolean values. We also have a few other operators that are interesting. So remember when I was saying you have parts of your code that give back Boolean values and other parts of the code that utilize Boolean values. So there are 3 operators that are distinctly both, not and or. So not true, can you guess? Not false? So that'll be not true is false, not false is true. I'll just make truth tables for these. If you've ever done like formal logic studying, you'll recognize you'll know what truth tables are, even if these don't totally look like what you're familiar with, but these are truth tables. So let's do true and true is true. And then we'll do this. And then let's do the same thing for or. Oops. And true or true, these are going to be true, and that one's going to be false. Let's just print. There we go. Okay, so for not, we've got false and true. For and, we've got true, false, false, false. And for or, we've got true, 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 false. So notice the inputs into these expressions are Booleans, right? These are our inputs, 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 and the outputs are also Booleans. So these both take in and give back Booleans. So you can use these to make more complicated and nuanced conditions that are capable for testing multiple other conditions in other ways. They are very handy. Cool, so the Boolean data type is only directly applicable to the exact values true and false, yes. What? The Boolean data type is only directly applicable. Oh, I'm being silly. So there's this thing that I avoid by principle, so I kind of misread that. And I don't really think about this because I avoid it by principle. And I kind of avoid it partly because I don't like teaching it because I think it can cause people to think that they should use this a lot. And it's a fairly, sometimes it's a useful feature. A lot of times, like especially when you're beginning programming, this can kind of get in your way. So take this as a bit of a grain of salt. There's something called truthiness and falsiness. So let's talk about truthiness and falsiness. So every other built-in data type in Python can be considered truthy or falsy when it's treated as a Boolean. So you can even use them in conditions and things, but it can create some confusion if you try to lean on this. So that's why I don't teach it. If you think about building your conditions as systems that return or evaluate to Boolean values, you'll have a more clean way of thinking about the code, and it gives you a kind of a stronger sense of what's going on, I think. But yeah. So let's look at integers. So this is actually going to be true for floats as well. Integers and floats whose values are equal to 0 are falsy. All other values for integers and floats are truthy, whether they're negative or positive. Negative 1, negative 1. We'll do positive. Let's do positive. With floats, it doesn't matter. Again, it doesn't matter like how close it is to 0. If I say 0. Oops. Let's do 0.0000001. This is still going to be truthy, right? So if the value is equal to 0, it's falsy. If it's not equal to 0, no matter what it is, it's truthy. For strings, if the string is empty, it's falsy. If there's anything in it, anything at all, it's truthy. And the same goes for lists. Empty list, or list with anything in it, anything at all, it's truthy. So that tends to hold. So if something is empty-ish, it's truthy or it's falsy. If it's 0-ish, it's falsy. If it's not empty-ish or not 0-ish, then it's truthy. So that's truthiness and falsiness. I got that one wrong because I always kind of avoid utilizing that. But in terms of just like raw problem solving, I'm not sure I've ever encountered something that like I couldn't. I'm certain, in fact, I haven't encountered any problems where I've had to, like, absolutely had to use truthiness and falsiness to solve those problems. Sometimes it can result in slightly cleaner code, but I tend to prefer code that is explicit over code that is clean. So if it takes me another line or something to make something that is clearer and more explicit, then I'm going to go for that every time. Write a function called isDifferenceTruthy. This function takes two numbers as an argument. We'll just call them A and B. It will subtract the two arguments and then return the result cast as a Boolean. Okay, so if the result is 0, we're going to return falsy, or we're going to return truthy. So I think if they're equal, I can do this in a totally different way. If they're equal, then that's the case where we'll return truthy. But it got me. I tried to, wait, what? Oh, return. I just wrote in the wrong keyword. I don't know why I did that. It's weird. Okay, I got another one. I'm trying to cheese this one, and it's not letting me. I like it when I can cheese the tests, though. It's fun. Okay, so it should just say A minus B, and we're going to return that as a Boolean. Oh, is that all it wanted? Oh, so let's see if I can do this. See if this is the same as saying A not equal to B. Yeah, okay. I just had that inverted. So this is going to be isDifferenceTruthy. So it's only going to be falsy if A and B are equal. So if A and B are not equal, then I can return true. So I can say A not equal B, which will be true if they're different. The reason I can say that is it's only going to return true, or it's only going to return false when A minus B equals 0. The only way for A minus B to equal 0 is for A and B to be the same number, because the only way to get a 0 from subtraction is to subtract a number from itself. So. Okay. Write a function called isGreaterThan, which takes two parameters, num1, num2. If num2 is greater than or equal to num1, return true, otherwise return num false. Okay, let's do this one. Def, take in this, num. I'm going to see if I can get it away with calling it A and B, and then I'm going to return A greater than or equal to B. Let's see, is it going to yell at me? All right, is greater than. If num2, oh, so that's B greater than or equal to A. I guess I could have done that. So that's correct. I suppose I could have done A less than B. Is that less than or equal? Ah, less than or equal. Okay. So different solutions for that one as well. Cool. All right, we're right about on our normal stopping time for the day. I'm going to wrap up here. Hopefully everybody enjoyed today's study hall. I know we're just kind of covering beginner material. Thanks for the question today. We only had one, but appreciate it. I'm going to be taking study hall this Wednesday and Friday, as Tovio is going to be out of town, so I'll have the next few study halls. Yeah, great. If you're in Premium Prep, I'll see you in there tonight, and you all have a good rest of your evening. All right, bye-bye.